Okay, so we're going to be doing 1.2c, inequalities with variables on both sides. So we've solved equations with variables on both sides, and we've solved inequalities. So we're just going to combine those skills that we have. Take a moment to pause the video to write down your lesson purpose if you haven't already, and we're going to get right into it. So directions. Remember, we always want to read directions to know what we're doing. Solve each inequality and graph the solution on the number line, show all your work. So I really like looking at the verbs that the directions are telling me to do to make sure I do all the things I need to do. So taking a look at problem number 1, just like with an equation, I'm going to bring the smaller variable over to the other side because I want to avoid dealing with negatives. So here I'm going to add 4x to both sides. When I do that, I end up with 5 plus 2x is greater than or equal to negative 11. From here, I'm going to subtract 5 on both sides to get 2x is greater than or equal to negative 16. And finally, I'm going to divide both sides by 2 to undo the multiplication to get x is greater than or equal to negative 8. When we graph our solution set, I always want to have 0. I want to have my boundary number, which in this case is negative 8. It's a closed circle because it's greater than or equal to and shaded to the right, meaning negative 8 and any number bigger than negative 8 is a solution, satisfies, makes that inequality true. Excellent, let's keep going. Okay, next one. Remember, this is a sneaky silent negative 1 that's being distributed. So from here, we have 3 minus x minus 1 is greater than 8x. I notice x is the smaller variable, and I can also combine like terms of 3 minus 1. So I'm going to add x to both sides, and 3 minus 1 is 2, is greater than 9x. From here, I'm going to divide both sides by 9, and I have 2/9 is greater than x. So we are interested in what x is being related to, not just 2/9. So from here, what I'm going to do is I'm going to switch the sides. And when I do that, remember, I need to flip the symbol. So this means x is less than 2/9 is my final answer. So from here, again, I want to have 0, and then I want my boundary number. In this case, it's 2/9. It's an open circle at 2/9 because it's not included. It's strictly less than, and all the numbers that are less than 2/9 are to the left. Perfect. At this point, if you feel confident and don't need any more explained, you can keep going and just check your answer. So you can use this video to pause, rewind, fast forward. You just do want to check your final solution set and your graph for each one of these before you turn this in. Awesome. Number 3, here I'm going to clear my fractions. I'm going to multiply everything by 2. When I do that, I end up with n plus 8 is greater than 2n minus 4. Smaller king is n. I'm going to subtract n from both sides. This makes a 0 pair. So I have 8 is greater than n minus 4. Undo subtraction with addition on both sides. From here, I end up with 12 is greater than n. But that doesn't tell me a lot about n, so remember, switch the sides, flip your symbol. N is less than 12 is my final answer. Boundary number is 12. That's to the right of 0. Open circle at 12, shaded to the left because that's where the numbers are less than. Okay, number 4. Taking a look here, I'm going to distribute this 3. When I do that, I get 3 minus 6n is greater than 3 minus 6n. Whoa, deja vu a little bit? Well, let's see. If you were going to add 6n to both sides, I end up with 3 is greater than 3. So our variables cancel out, and we've looked at this in equations and inequalities before, so what's really important is what type of statement we have. So here we have 3 is greater than 3. Is this true or false? Is 3 greater than 3 or is it equal to 3? 3 is equal to 3, it's not greater than. So this is a false statement. So I want to recall our definition of a solution. Because this is a false statement, the answer is no solution. we're going to leave this intentionally blank. Leave this intentionally blank. So because this is a false statement, remember our definition of a solution, any value or values, if there is one, when substituted in makes the statement true. So here, because our variable terms will always cancel out in our solving process, leaving us with a false statement, there is no number in the whole wide world that will ever make this true. Cool. So makes the graphing easy. Okay, number 5. Taking a look here, I'm going to distribute my -4. Notice I like to circle the negative when I'm distributing it just so I don't make a silly mistake. 28 minus 7x is less than or equal to 28x plus 28. Add 7x to both sides. You got kind of fooled up with all these 28s, got 28 happy. I was like, what? So negative 7x is a smaller variable, so I'm going to add 7x to both sides, making this a 0 pair. And from here, we have 28 is less than or equal to 35x plus 28. From here, I need to isolate my variable. I'm going to do the addition with subtraction. Here, I get 0 is less than or equal to 35x. Divide both sides by 35. 0 divided by any non-zero number is 0. So what we have here is 0 is less than or equal to x. But remember, we want our variable term in front, so I'm going to switch the sides and flip my symbol to know that x is greater than or equal to 0. So here we have 0 is our boundary number and 0. 2 for closed circle at 0 and shaded to the right, because all the numbers that are bigger or greater than x, 0, are to the right. So x is greater than or equal to 0, 0, and all the numbers that are bigger than 0. Okay, this next one, I'm going to clear my fraction by multiplying everything by 5. When I do that, I get a minus 45 is greater than 5a minus 45. Finding the smaller variable, it's a. I'm going to subtract a from both sides. Careful with your negatives. This is a negative 45 is greater than 4a minus 45. Add 45 to both sides. I have 0 is greater than 4a. Divide both sides by 4 to undo multiplication. 0 divided by any non-zero number is 0. So I have 0 is greater than a. Of course, I want my variable in front, so I'm going to switch the sides and flip my symbol. So my final answer, I'm just going to write it over here, is a is less than 0. Oops, forgot to box my answer over there. So here I'm going to have 0 as my boundary number and 0. It's an open circle at 0 and shaded to the left because that's where all the numbers are less than. Perfect. Moving right along. Taking a look at number 7, of course, I want to think about clearing my fraction here. I want to think about clearing my fraction here, so I'm going to multiply both sides by 4. When I do that, I end up, sorry about that. I end up with 3a is less than 2a plus 60. Smaller variable is 2a, so I'm going to subtract 2a from both sides. When I do that, I have a is less than 60 as my final answer for my solution set. So I'm going to have my 0, I'm going to have my boundary number 60. It's an open circle at 60, and we're shading to the left because that's where the values are less than. Perfect. Taking a look at the next one, I have some decimals, so I'm going to clear my decimals to make it a little easier on myself. And when I do that, multiply everything by 10 because there's only one decimal place that I'm getting rid of. I end up with 21n minus 40 less than or equal to 80n plus 40 minus 59n. So before we start inverse operations, I love to simplify. So I have 80n minus 59n. So we're still going to have 21n minus 40 is less than or equal to, and 80 minus 59 gets me 21. 21n plus 40. Looking here, same 21n on both sides. So let's see what type of statement we have. Negative 40 is less than or equal to positive 40. This is a true statement. Remember, once your variables cancel out, we have to look at what type of statement we have to know if any number will make this true or no numbers will make this true. So since this is a true statement, I know that this is all real numbers. Since this is all real numbers, I'm going to graph 0 on my number line. I'm going to put a closed circle at 0 and shade to the left and to the right. If it was an open circle at 0, it would be all the numbers except 0, but we know 0 also makes this true. Some people might also call this infinitely many solutions, but remember, a solution set is infinitely large, so all real numbers is most appropriate. Okay, taking a look at number 9. Taking a look at number 9 here, you can distribute first to clear your fraction, but you could also clear the fraction before you distribute. Just mathematician beware. Be really careful here that you're not going to double multiply on this side, because if we multiply the 3/2 by 4 and the x by 4 and the -2 by 4, then we're going to be multiplying the 4x and the -8 again by 4 when we multiply it by the 6 on the outside. And that is going to be not okay because we're not doing the same operation to each term. So from here, what we have is 6 times the quantity of x minus 2 is greater than 1 minus 4x. I'm going to distribute, so I have 6x minus 12 is greater than 1 minus 4x. The smaller variable is 4x, so I'm going to add 4x to both sides. When I do that, I end up with 10x minus 12 is greater than 1. Now I'm going to isolate my variable by adding 12 to both sides and move up here. So I have 10x is greater than 13, Taylor Swift's favorite number. Divide both sides by 10, and x is greater than 13 over 10. So notice, because we have fractions in our original problem, I want to have fractions in my answer. I do not want to use decimals. So taking a look here, 0, 13/10 is positive, so it's to the right of 0. We have an open circle at 13/10 because it's not included and it's greater than, so we're shading to the right. Awesome. Next problem. Next problem, first to simplify, I have to distribute that -7. Did you notice it was a -7? From here, we have 13 minus 7x minus 14 plus 9x is less than or equal to 10x. I'm going to sort my like terms, so I have a -7x and a 9x and a -14 and a +13. So when I combine all those like terms, I do end up with -1 plus 2x is less than or equal to 10x. From here, I'm going to get rid of the smaller variable, so -2x to both sides, and I end up with -1 is less than or equal to 8x. Divide both sides by 8, and I have -1/8 is less than or equal to x. Of course, I want to know what x is, though, so I'm going to switch the sides and flip my symbol. X is greater than or equal to -1/8. My final answer, my solution set. Put in 0, put in my boundary number, and notice it's a negative, so it's to the left of 0. And here it's going to be a closed circle and shading to the right because x is greater than, and that's where numbers are bigger, to the right. Awesome. 2 more problems to go over. Hopefully you were able to do these on your own and you're just checking your answer. Good job, good job. So from here, be really careful because I do need to distribute this -5 and I also need to distribute this 2. So when I do that, I end up with 8 minus 5t. Be careful with t's, you guys. I mean, some variables, they really look like other numbers or math symbols, so just be careful. Sometimes I like to put a little flair to my t, but we don't want to change the actual variable or make it a capital or anything. So I'm just going to make sure that it looks kind of like a cursive t. Plus 5, negative times a negative is a positive. Less than 6 minus 2t, put a little flair to it, minus 3t. From here, I'm going to combine my like terms. So on this side, I have 8 and I have 5. On this side, I have -2t and -3t. So from here, I have -5t plus 13 is less than 6 minus 5t. From here, if I add 5t to both sides, I notice that my variable term cancels out. Well, what do we know? Well, it's either going to be no solution or all real numbers. So let's take a look at this statement. 13 is less than 6. And remember, if you're having a hard time remembering what this inequality symbol means, you can always make an L with your hands and you can squish it, and squishy L always means less than. So squishy L if you get stuck or confused. So 13 is less than 6. True or false? This is a false statement. This is a false statement. And because this is a false statement, it means any number that I substitute in for this inequality is going to cancel out, leaving with the false statement, meaning by definition of a solution, there is no solution. Leave this number line intentionally blank. Don't touch it. Don't touch it. Don't. Ah. Okay. Number 12. So taking a look here, I see that I have a 4 on this side and a 2 on that side. If you did want to do cross multiplication, you just have to make sure that the numerator on the left stays on the left side. It's one of those funny rules just to keep that inequality relationship true. Typically, if I had a proportion like x over 3 equals 5/2, I could put x times 2 on either side. But because if this was an inequality now, I'd have to put the 2x on the left in front to be able to solve. So just, word to the wise if you wanted to do that method. I'm going to clear my fraction just because if I multiply both sides by 4, or think about it as 4 over 1, I notice that these 4s cancel out. This 2 becomes a 1 and this 4 becomes a 2. So that's going to help me out a lot because since these 4s are gone, I'm just left with 2x minus 1 is greater than or equal to 2 groups of 4 minus 5x. So from here, I'm just going to do a little bit more simplifying of distributing. 2x minus 1 is greater than or equal to 8 minus 10x. From here, the lesser variable is negative 10x, so I'm going to add 10x to both sides. When I do that, I end up with 12x minus 1 is greater than or equal to 8. I'm going to add 1 to both sides. When I do that, I'm going to move up here. I have 12x is greater than or equal to 9. Divide both sides by 12, and of course reduce. Notice scale down by 3. I get my final answer of x is greater than or equal to 3/4. My final answer, the final answer of the final problem. And just to graph, 0, and then my boundary number 3/4 is to the right of 0 because it is positive. We have a closed circle because it is greater than or equal to, and greater numbers are to the right. So I'm going to graph to the right. Excellent job, my mini mathematicians. Thank you so much for your hard work, and I will see you next time.